So I wanted to go through what it was I've been working on lately. It started out with these little Minecraft blocks. This is a redstone block that you can pick up at GameStop and other locations. It's got a little circuit inside that each time it triggers, it'll change the brightness of the block. I thought they were pretty cool, so I picked one up, and I noticed right away that they have redstone blocks and then they have diamond blocks. But you have to buy a separate one because it's only one color per block. So instead of buying a second one, I decided I would create one of my own. And instead of just picking a single color, I've put together a little circuit inside that has red, green, blue LEDs on each corner that let me pick a color. So when I tilt it one way, it'll turn green. Tilt it another way, give me red, and mix those two colors together. Tilt it a third way, and it'll give me blue. And I can get basically any color that I want that way by the different combinations. And each time it tips, when it shows whatever color is being cycled through, it'll fade the color in and then fade the color back out again. So I can get all kinds of combinations now instead of just a single red or a single yellow or a single blue block. I can get purples, oranges, greens, whatever it is that I want to use. So I set the circuit up fairly straightforward in the inside here. It's straightforward, but it kind of looks like a mess. So the circuit itself is an Arduino. Here in the bottom, you can barely see it. It's an Arduino Micro. I then used a little DC to DC boost converter so that I can plug in two AA batteries, which are typically roughly 1.5 volts each, so you get about 3 volts. Well, the Arduino needs 5 volts, so this converter takes your 3 volts, boosts it up to 5, and then outputs 5 volts to whatever you need to run. So this converter goes to 5 volts to here. I have 4 of those red, green, blue LEDs on each corner. Each of those are tied together into a single block, which is kind of a messy looking block, but it has each of the channels, red, green, blue, and then the base, the collector. I also have a 5th red, green, blue here in the side, and that's the one that when it's tipped, it'll show you which color is being actually activated by the tilt sensors at the top here. So these are just little tilt sensors that have a ball bearing inside, and it has 2 wires out the back here. And when you tip it this way, the ball bearing falls down and makes contact with both of those wires, and then triggers that particular sensor on the Arduino to say, do whatever. So if it's tilted this way, this is my red sensor, it'll trigger turning on the red color. Tilt it this way, gives me the blue color. This way, gives me the green color. So it looks, like I said, kind of messy. All the pieces came together though, and it fits pretty well in the box that I designed. The batteries, actually this entire box, is 3D printed on my printer. So I created, first of all, the battery holder on the bottom with a battery clip that has a single switch that you can attach on the bottom. It also has one other feature is you can switch between battery and USB. The battery is the 2 AA's that are in the bottom here. So when you tip it, it shows what color is being selected. If you don't want to work with batteries, you can turn that off. Well, technically you switch it to USB, which is off for battery. And then I have a USB port, micro USB, that you can just plug in with a standard micro USB 5 volt adapter. And then it does the same thing. Power goes through. Since it's already 5 volt, it doesn't have to go through the DC boost converter. It just goes direct into the rest of the circuit. And then has the same process. Now to show you the color a little bit better here, it's usually easier to plug it back in. So if I want red, you can see that the red will cycle up to full brightness, and then it'll cycle down, get dimmer and dimmer, and then go out. And then it'll come back up, full brightness, and it goes down. So I have that in the Arduino, so every time this triggers a certain color, that's what it'll do. It'll cycle down to nothing, up to full, and then just go back and forth, so you can do your color mixing by the amount of time you keep it tilted. So overall, I think it went pretty well. The rest of the 3D print was after I printed the base. I printed 4 panels, one of which is different with this notch cutout so that I can put in the USB port at the bottom here. And then these 4 panels each have a single connector with a M3 nut inside. There's a little slot that the nut gets slid into. And then these M3, keep saying it the wrong way, M3 bolts just screw right into that through the holes that I put in the corner of each of the base platform. These 4 panels were printed out. A 5th panel was printed on the top. That's a little bit different because it doesn't need these bolts sections, so it's just a single square all by itself. And then each of these sections has the color that you see showing through the inside as different designs. When I printed it out, the original block has, you can tell, and just like in Minecraft, different shades of red and different shades of gray. I knew I couldn't get the shades of gray, but I attempted to make different depths of the clear color inside to make it look a little bit different, some a little darker, some a little lighter. It turns out the LEDs are bright enough that it washes out any of the, at least by the amount that I stepped it higher or lower, any of the difference between a thinner or a thicker piece. So put all of that together, hot glued all the pieces together. First of all, the insert into the sides, and then hot glued 3 of the sides together, then the top, and then finally put the 4th side on and was just able to get the hot glue gun in far enough to get most of the sections glued together. It worked out pretty well. The very last one I put together, there's a bit of a seam that didn't quite close up as well as I'd like, but most of them closed pretty nicely. So that gives me just a couple of these screws in the corner, my own Minecraft block that I can tune to be either a redstone block or a diamond block or pretty much any color that I want. And then one of the last pieces available here, I haven't really tested it yet to find out exactly how long the battery will last, but if you eventually get to the point that the battery does die and you're still in the dark, it might not show on the camera there very well, but the individual piece that is built in, or the color blocks inside, I printed in glow-in-the-dark PLA, so that when the lights go out, all of these glow a nice ghostly green. So that is what has kept me busy for my project for about 3 weeks now, 2.5 weeks. Once I finally put all this together, I got all the circuitry the way I liked it. I realized after looking at some other tutorials online that there's a simpler way to do this. I used an Arduino with a whole bunch of circuitry to get 5 LEDs. What I can do instead is they make something called NeoPixels. This is, if you go to Adafruit's website, she is one of the most popular ones, or possibly was designed the original one. But these pixels, as they call them, are red, green, blue LEDs in a little package with their own resistors that you can tie into an Arduino, or an ATtiny in this case, which is a little circuit, a little chip that can run Arduino code. And it takes a power, ground, and a signal wire in order to get any mixture of the colors that you want. Unlike the 4 wires that I have to run to the LEDs, which then also take up 4 different signals pins on your Arduino. So the next version of this will be something with much smaller circuitry inside. But overall, I'm still happy with this. It worked out pretty much as well as I wanted it to. It was one of the more complex 3D designs that I've put together, especially for the base. Just figuring out how to get the section for the switch, making sure that all the holes for the different bolts that I put in would fit, getting the USB to fit correctly on the side. I'm pretty happy with it. So there you go.